Good afternoon, everyone. Today I discussed about fifth unit. In that fifth unit, bioremediation. Here we discussed about the bioremediation. Why we need to study about bioremediation? What are the advantages of bioremediation? Bioremediation techniques, in situ techniques, ex situ techniques, phytoremediation, microorganisms used in bioremediation, disadvantages, conclusion, and references. Here we have to discuss too in this lecture. So, what is meant by bioremediation? Bioremediation is nothing but refers to the process of using microorganisms to remove the environment pollutants or prevent pollution. So, bioremediation is the one of the bioremedial technique which is used for the soil, water, air, other hazardous waste also we have to use. For this one, bioremediation means we have to add microorganisms to the environment, to the soil, to remove the environment pollution or prevent the pollution. So, the removal of organic waste by microbes for environment cleanup is the essence of bioremediation. Our objective is to remove the excess waste of the soil. So for that one we need to add the microorganisms. Other names for the bioremediation is biotreatment, bioreclamation, and biorestoration. So why we need to study bioremediation for contaminated soil or wasteland? So every day increase the industrialization and increased use of chemicals in manufacturing process have resulted in the generation of a large amount of chemical waste. These waste products are most often being dumped on the land and in water bodies, so that the water contaminated and gives the hazard effects to the people and population. So that's why we need to remove the waste from the water. This continued dumping has definitely speeded up the process of land pollution. So continuous dumping is also occurred. For the stopping of the dumping process, we need to use the remedial measures. Among that, bioremediation is the one of the technique. So what are the advantages? Here we need to study. So can be done on site. Bioremediation is the simple process without disturbing the soil or without disturbing the site. Easily remove the contaminated soil, contamination of the ground. So minimum site disruption is caused. It is the first advantage of the minimum site disruption is caused. For example, remedial techniques are 14 is there. First one is excavation and changes. So in that one, site disruption is occur more. Here, bioremediation there is no site disruption. Elimination, transportation cost and liabilities. Eliminate long-term liabilities. Uses biological systems, often less expensive. Can be coupled with other treatment techniques. Easily coupled with biotreatment for the other techniques also. And nowadays biotreatment is used for all the purposes. Simply we didn't disturb the any part or structure, easily recover the unhealthy condition. So that's why it is rapidly increasing. Safer and the other methods of cleanup, less destruction of the environment. Most approaches convert harmful pollutants into relatively harmless materials such as carbon dioxide, pollutant, chloride, water, and other simple organic molecules we have to use and easily remove the pollution from the water or soil. So bioremediation techniques are three types is there. First one is in situ techniques, ex situ, phytoremediation. So bioremediation on land, in situ techniques we are having the 5 different types. Bioremediation on land, land farming, bio venting, biosparking, bioaugmentation. So ex situ we see the composting, biopole process, bioreactors. Phytoremediation, phytostabilization, for phytovolatilization, phytoextraction, phytotransformation, phytostimulation. So these are the 3 different types of techniques used in the bioremediation. In situ remediation techniques, contaminated groundwater on land is treated place without excavation. Without excavation, we have to contaminate and easily cure. Bioremediation on land depend on the area contaminated, the properties of the compounds involved, the concentration of contaminants, time required to complete the bioremediation. The contamination can be treated on site or the contaminated material excavated and treated on or site. If contaminated is water soluble, a pump and treat techniques are used, introduced into contaminated areas and removed at another site to be treated on or off site. Land farming, the simplest of the on-site treatment. So one of the bioremediation technique in situ technique, land farming. It is the simplest form of the on-site treatment. So plugging increases oxygen levels in the soil and disturb contaminated more evenly with increase the rate of degradation. So oxygen levels increases in the soil and disturb the contaminated more evenly. So nutrients added to increase the biodegradation. In land farming technique, we have to use this the nutrients, that means potassium, calcium, like that we have to nutrients we have added to the biodegradation. 4 to 6 months required to remove contaminants such as PHS method is best suited for shallow contaminated of soil surface. Treatment area is lined and dammed to retain any contamination. Rate of degradation depends on the microbial pollution, the type and level of contamination and the soil type. Rate of degradation depends upon microbial pollution, the type and level of contamination and the soil type. Average half-life for the degradation of diesel, fuel and heavy oils is in the order of 54 days with this type of system. So like that we have to study. Here we see the land farming technique. It is the one of the bioremediation technique. 3 to 4 months will be taken. This image gives very clear bioventing. Second process is bioventing. In situ process which combines an increased oxygen supply with vapor extraction. With vapor extraction, increasing the oxygen, a vacuum is applied at some depth in the contaminated soil, employs low air flow rates and provides only the amount of oxygen necessary for the biodegradation. Nutrient supplementation can be provided by the running nutrients into trenches dug across the site. The increased supply of air will increase the rate of natural degradation by aerobic microorganism. So two venting pipes is there. Left side we have to keep one thing and right side we have to place the another venting pipe. In one venting pipe takes the disposal hazardous air to the left venting pipe and next venting vacuum pump we have to give to the bioventing. Biosparging. So what is meant by biosparging? To increase the biological activity of soil by increasing supply of oxygen by sparging or air oxygen into the soil, supply of hydrogen peroxide and toxic at low concentration to microbes. Success depends on the structure of the soil. Ground surface, contaminated soil and water soluble groundwater, microbial degradation, air injection is there. So by injecting the air, microbial degradation simply killing the pathogens, bacteria in the soil and water. Bioaugmentation, it is the fourth technique of the bioremediation. Bioaugmentation, what is meant by bioaugmentation means is the addition of bacteria culture required to speed up the rate of degradation of the contaminant. So as early as possible we finish the task. For that reason we have to introduce the bioaugmentation, supplement the existing microbial community in order to improve its functionality. For improving the functionality we have to increasing our growth to the microbial microbes. Bioaugmentation has been successfully performed by using activated soil rather than pure culture. Before bioaugmentation, after bioaugmentation. Desired microorganisms, other microorganisms is there. Ex situ remedial techniques. In ex situ remedial techniques means we have to disturb the soil. If the contaminated material is excavated, it can be treated on off-site, which is often a more rapid method of decontaminating the area. In that, first one is composting. Solid phase treatment carried out after extraction. The composting material such as straw, bark and wood chips is mixed with contaminated soil piled into heaps. Process working the same way as the normal system, which rise the temperature 60 degrees centigrade and above cause microbial activity. Higher temperature encourages the growth of thermophilic bacteria. Increased cost of this system restrict it to highly contaminated materials. Organic materials added to vegetable, fruit and garden waste added at a concentration rate of 33 to 75%. Temperature above 70 degrees centigrade, which after 60 to 20 days of incubation with turning every 7 days, and 84 to 86% of the contamination was removed by 40% contamination by 35% untreated soil. So already in previous unit we discussed about the composting. Composting is nothing but soil merged with hazardous waste. So layer by layer we have to fill in the composting. After 3 to 4 months we getting the humus product, that is the quality of the humus. Based on the color of the humus we have identify the quality. Biopiles process. Soil heaped into piles within a lined area to prevent leaching. Piles covered with polythene and liquid nutrients applied to the surface. Aeration improved by applying suction to the base of the pile as in a composting system. Leachate collected by pipes at the base and recycled if necessary. Space limited. So in biopile process we see the instrument. So first one we have to consider as the clean soil base. Contaminated soil is there. Contaminated soil, from contaminated soil we have to taking the extraction pipe is connected to the condensation collection tank. After that a blower, this one transfers the gas treatment. So next one is treated of gas. Bioreactor. Soil extracted from a contaminated site can be treated as solid waste or liquid leachate in bioreactors of various designs. So control of parameters such as temperature, pH, mixing, oxygen supply, improve degradation rates. Used for solid waste slurries can be solid bed, fluidized bed and sterile tank bioreactors. Phytoremediation. Third method is phytoremediation. What is meant by phytoremediation means plants also takes the phytoremedy is a living organ. Green plants for in situ risk reduction. So plants also taking the risk for the growing the plants. That's why we have to add the removal of contaminants from contaminated soil, water, sediments and air. Phytovolatilization. Plants uptake contaminated which are water soluble and release them into atmosphere as they transfer the water. The contaminated may become modified along the way as the water travels along the plant's vascular system from the roots to the leaves, whereby the contaminants evaporates or volatilizes into air surrounding the plant. Poplar trees volatilizes up to 90% of the TCE observed. Selenium and mercury takes the tobacco plants. Phytodegradation means it is the degradation or breakdown of organic contaminants by internal and external metabolic process driven by the plant. Plant enzymatic activity, oxygen and nitrogen base. Explosives, photosynthetic oxidation used in breakdown of ammunition waste, chlorinated solvents such as TCE, trichloroethane, degradation of organic herbicides. Reserve filtration. It is concerned with remediation of contaminated groundwater. The contaminants are either absorbed onto this root surface or absorbed with the plant roots. Plants used for reserve filtration are accumulated to the plant. So plants are hydroponically grown. Its roots also we take the harvesting. So biofiltration is almost nowadays we have used. Thank you.